Hello Year 8, we are starting a new topic this morning. Okay, you did some graph work last week. The graph work I've seen was very good. Okay, we've got a bit more graph work to do when we're back in school, but that's a little bit tricky to do over the internet, so we'll come back to that one when we're back in school. Okay, so the topic we're moving on to is sequences. And a sequence is, and you'll have to write this down in your books by the way, a sequence is just a set of numbers where each number is related to the one before. Okay, or you could say that they're a set of numbers where they just follow a rule. Okay, it's any set of numbers as long as you're following a rule, as long as each number is related to the one before in the same way every time, then it's a sequence. Okay, it's not just a random set of numbers. And the easiest sequence in the world, the one you learned when you were probably 2 or 3 years old, is 1, 2, 3, 4, 5, 6, 7. Okay, some people call it counting, some people call it the one times table, some people say you add one every time. The posh name for that is the natural number sequence. Okay, it is the very basis of all our times tables really. Okay, because when you say a times table you go 1 times something, 2 times something, 3 times something, 4 times something. Okay, the very basic blocks of maths is a natural number sequence. Okay. Now what I've got on the next slide, so pause it if you're not ready to move on. I've got some sequences, 7 sequences, and they all follow a rule. Okay, some of them are harder than others. And what I'd like you to do is to pause the video, and I'd like you to figure out the next 3 numbers in each of the sequences. So copy down what I've got so far. So for example, on number 1, I've already got 2, 4, 6, 8, 10, 12. What I'd like you to do is write down the next 3. Hopefully you've spotted that that's a 2 times table. So it goes 14, 16, 18 would be the next 3. Okay, so pause the video and do the same for all of these from A down to G. They get trickier towards the bottom. Don't give up too easily. Press play when you're ready to hear my answers. Okay, B is actually really similar to A because it's going up in 2s like the 2 times table, but we're starting on 1. So these are all the odd numbers really, okay, but they're going up in 2s every time. So you should have 13, 15, 17. This one goes 3, 7, 11, 15, 19. Hopefully you spotted it's going up in 4s. It's not the 4 times table, but it does go up in 4s, okay. So the next one would be 23, then 27, and then 31. Okay, and they get a little bit trickier. If you look at this, it goes a gap of 1, then a gap of 2, then a gap of 4, then a gap of 8. So the gap is different every time. So it's not like a times table. Okay, but the link this time is that you double the number before. Okay, so I double 1, you get 2. Double 2 is 4. Double 4 is 8, double 8 is 16, double 16 is 32, double 32 is 64, and double 64 is 128. Okay, and if you're into your computing, what you might want to look up is something called binary. Okay, when we say they talk in 1s and 0s, they're using this sequence of numbers in reverse admittedly, but you can make any number you like by either turning on or off each of these. Okay, and that's what binary is in computing talk. So if I wanted to make, so what you do, as a little example, if I put that sequence backwards, if I wanted to make the number 50, I need one of those, 32, I'll have one of those because that makes 48. I don't need any of those, I don't need any of those, I need one of those and one of those, none of those. So 50 in binary is 110, 010. Okay, so that would make 50. If I wanted to make 25, I don't need a 32, so if this is at the beginning you just don't count it, so I'll have one of those and one of those, that makes 24. None of those, and one of those makes 25. And that's how computers work in 1s and 0s, but can make other numbers. Okay, so it's all to do with doubling every time, and you can make any number you like by just having on or off 1s and 0s. Okay, Right, E, what's happening here? It goes 1, 4, 9, 16, 25. If you look at the gaps, it goes 3, 5, 7, 9. And there is actually a pattern down there. So it goes 3, 5, 7, 9, 11 makes 36. Okay. 13 makes 49. And 15 makes 64. But actually, you may have spotted that these are the square numbers. Okay, 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. And then we've got 6 squared, 7 squared, and 8 squared. Okay, but within the square numbers, it does go, the gaps go gap of 3, gap of 5, gap of 7, gap of 9, and they get bigger every time by 2. Okay. Right, F, the numbers are getting smaller. I'll change to a green pen for F. So the numbers are getting smaller for F. It goes down by 1. So take away 1, take away 2, take away 3, take away 4. Next would be take away 5. Next would be take away 6, 79. And next would be take away 7, 72. Okay, there's not a specific name for that. Okay, it's just a little pattern I made up where you take away 1 more than last time. And G is a very important sequence of numbers, and I might give you a little bit of research to do next week on this one. This one probably had you stumped. The way this sequence works, you've got to start 1, 1. 1 add 1 is 2. 1 add 2 is 3. I'll change colour for this. 2 add 3 is 5. 3 add 5 makes 8. 5 add 8 makes 13, and so on. So you add the two previous numbers together to get the next number. So 21 and 34 makes 55. Okay. So 21 add 34. 34 add 55 is 89. 34 add 55. Okay. And 55 add 89, what's that? 144. Okay, so that's 55, whoops, add 89. So you add the two previous numbers together, and this is called the Fibonacci sequence. Okay, I won't go too much into it now, but the Fibonacci sequence gives us something called the golden ratio, which naturally occurs everywhere. I think I'll give you a little bit of research on that next week, but it's a very, very important sequence of numbers. Okay. Hopefully you managed to get most of those. Okay. Right. So a little bit of note taking now then. So trying to describe a sequence with words and sentences can be tricky. Okay. So we try, if we can, to come up with like a mathematical way of writing down, like in algebra, really. Okay. But we call each number in the sequence a term. Okay, so this is new language, so you'll need to write this down. A term is just a number in a sequence. So there's the first term in this sequence, there's the second term, there's the third term. It just means what number in the sequence are you talking about. This would be the fifth term, because it's the fifth number in the list. This would be the sixth term, because it's the sixth number in the list. Okay, but a term is just a number in a list. And for a bonus point, what is the pattern for this sequence? We are going up in threes. Okay, but it's not 3 times table, because the 3 times table goes 3, 6, 9. It's close to the 3 times table, it goes 2, 5, 8. Okay, and that's something we'll come back to next lesson. Okay, so make sure you've got this down, that when we say a term, what we mean is just one of the numbers in the sequence. Okay. And then the last thing I want you to do in this lesson is to write the first 5 terms for each of these sequences. So I've given you the rule, and I want you to follow the rule and write me the first 5 terms, so the first 5 numbers in the sequence. Okay, I'll do the first one with you, and then I want you to pause the video and do the rest yourself. So it says start on 8, so my first term is 8. And go up in threes. So my second term will be 11, then 14, then 17, and then 20. And And what we do is we put dot 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 on the end to show that the sequence does keep going, but we're not going to write down the rest of it. So pause the video, and I'd want you just to write down the first 5 terms for each of those 6 more sequences that I've given you the rule for. When you've done them, play the video and check your answers, and that's all I want you to do today. Okay, starting on 100 then, so my first term's 100, go down in 7s, so we've got 93, 86, 79, and 72, dot dot dot. Start on 400 and half the previous number, so to get the next number I do half of 400, which is 200, half of 200, which is 100, half of 100 is 50, and half of 50 is 25. Okay, for the next one we're going to start on 3 and double, so 3, double 3 is 6, double 6 is 12, double 12 is 24, and double 24 is 48. Okay, you won't want to go much further with that because numbers will get massive. Okay, E, the 8 times table with 5 added on each time. So first of all I'm going to do just small tiny amount, is write down the 8 times table. So 8, 16, 24, 32, 40. And now I'll add 5 onto each of those. So instead of 8 we'll get 13. Instead of 16, 21. Instead of 24 it'll be 29. Instead of 32, it'll be 37, and instead of 40, it'll be 45. So the little writing up there is the 8 times table, and then the main sequence underneath is when I added 5 on as well. Okay, I'll do something similar for F look, so the 6 times table with 2 taken away. So let's write down the 6 times table first. 6, 12, 18, 24, 30. If I take away 2, I get 4, 10, 16, 22, 28, dot dot dot, should put a dot 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 on that one as well. And then the last one for today, the 4 times table with 10 taken away every time. So it goes 4, 8, 12, 16, 20. That's the 4 times table. Okay. If I take away 10, a little bit tricky, be careful, we get minus 6, minus 2, 2, 6 and 10. Now what you'll notice about these last 3, on E, even though I took away 5, look, the numbers still go up in 8s. Okay, and they go up in 8 because I started with the 8 times table. Okay, so they still go up in 8. Just because I took away 5, they still go up in 8s. If you look at F, okay, I took away 2 from each of these, but they do still go up in 6s. Okay, because I did still start with the 6 times table. Adding and taking away doesn't change the fact that the sequence is going to go up in 6s. And even on the bottom one, where we started with the 4 times table and took away 10 and we went negative, look, it still goes up 4, then another 4, then another 4, and then another 4. And what that shows you is that if you can spot the gap size between the numbers, you can work out what times table a sequence is based on. And if you know what times table it's using, that's halfway there for writing the algebra for a sequence instead of writing a sentence. But we'll look at those next lesson.